Section 9.1, Example 3 on page 690, we have recursive definitions can be very helpful when you look at a small section of a sequence. However, if you want to know both a sub 3 and a sub 5000 of a sequence, an explicit formula often works better. So this time I have labeled the pyramids in sequence numbers. So this one block is going to be our first term, the next 3 blocks are going to be our second term, the 6 blocks are going to be our third term, and so on. Next, this table will help us expand our first few terms. So the first one is just 1. Our second term is 3, which was 1 plus 2 more. Our third term is 1 plus 2 plus 3 more, which gives us 6. Our fourth term is 1 plus 2 plus 3 plus 4, which gives us 10. Our fifth term is 1 plus 2 plus 3 plus 4 plus 5, which gives us 15, and so on. So if we continue this pattern, our a sub n term will be 1 plus 2 all the way up till n. Therefore, we can write out the a sub nth term as 1 plus 2 plus 3, and so on, all the way up to n minus 2 plus n minus 1 plus n. If we write this the opposite direction, we can also say a sub n is equal to n plus n minus 1 plus n minus 2 plus all the way till we get to 3 plus 2 plus 1. Therefore, we can add a sub n to itself and get 1 plus n plus 2 plus n minus 1 plus 3 plus n minus 2, and so on till we get to n minus 2 plus 3 plus n minus 1 plus 2 plus n plus 1. If you add straight down, we get n plus 1. 2 plus n minus 1 gives us, again, n plus 1 because we have n, and 2 minus 1 gives us another 1. If we have 3 and n minus 2, 3 minus 2 is 1, plus our n gives us n plus 1, and this continues all the way until the very end where we have exactly n plus 1. If you count how many times we have n plus 1, we'll get exactly n because this went from 1 to n, and this went from n to 1, so this occurs exactly n times. So we can rewrite this as n plus 1 times n, and here we had a sub n plus a sub n, which gives us 2 times a sub n. Now we can divide both sides by 2 to get a sub n equals 1/2 of n times n plus 1. This gives us an explicit formula for a sub n. Therefore, if we're looking for the nth term, we don't need any other terms, we can just plug in n. Since we're looking for the 100th term, we can plug in 100 to get 1/2 of 100 times 100 plus 1, which is 101. Half of 100 is 50, so we get 50 times 101, or 5,050. So the 100th term of this sequence would be 5,050, meaning we would use 5,050 different blocks to make the 100th pyramid. The work for this problem is written out on the next few slides. And now I would like you to try number 6. Find the 8th term of the sequence 2, 1, -2, -7, -14.